Okay. So today we are going to discuss a new topic about rotation. If any body is rotating about the fixed axis, what is the fixed axis? There may be some axis of rotation. Based on the axis of rotation, some body will rotating. For example, you can consider this picture. I have an object. It will be like this, and I would like to rotate this object based on some fixed axis. So that is, what is my fixed axis? This is my fixed axis. So this is my fixed axis, and your object will be rotating in this direction. So now you can see your object, the entire object is rotating about this axis of rotation. So if any object is rotating about the axis of rotation, what are the parameters you are going to study? Clear? That's what the title is given as, rotation of a rigid body. This is our rigid body. Rigid body is nothing but it's a solid body. So solid, if any body is rotating about any axis of rotation, we are going to study some physical parameter. So this information we are going to study in chapter number 10. Clear? Okay. Before we start, first of all, we have to study some variables. What are the variables? Variables is nothing but we are just going to study some important variables which will be which you are going to apply for studying the concept of rotation. Better we can just start from this diagram. What is given in the diagram? And please read what is given in the slide. A rigid body. What is our rigid body? This oval shaped object is our rigid body. You can consider this is our rigid body, and this body is rotating. So this is our axis of rotation. So this is our axis of rotation. So based on this axis, our object is rotating in this direction. Now you can see, first I am going to consider this position. So based on this position, my object is starting to rotate. So that information is given in the slide. A rigid body, so this is our rigid body that can rotate with all its parts locked together. For example, if you take any rigid body, consider this is my rigid body, and this rigid body is made up of small particles. Am I right? So for example, consider it's a collection of small particles. So this particle, this particle, this particle. So many small particles are inside the rigid body, because when you just combine all these small particles, you can form a big particle, big object, big body. Am I right? So the collection of these small particles make a big solid rigid body. Now, if you just make any axis of rotation, for example, based on this axis, my entire body is rotating. Now you can see the entire body is rotating because of all other parts is also rotating about the same axis. So that information is given here. You can see a rigid body is a body that can rotate with all its parts. What is all its parts? All small particles. With all its parts locked together and without any change in shape. So when the object is rotating, their shape will be changed. This body
No,
is
no,
rotating
sir.
about,
Just
so
one question.
yes, just it is rotating about the fixed axis. That means the object will not moving left and right hand direction. Only it will be rotating about the axis of rotation. So what is fixed axis? Here our fixed axis is this. Now we can consider, so this is my axis of, this is my reference point. So first my object is rotating about this reference point. Now when the object is rotating, this particle will come to this point, and after it rotating, the particle from this point will be coming to this reference line. That means whatever the object will be rotating, first of all you have to consider the reference point. The reference point is very important when you are studying the concept of any object is under motion. So today we are going to study a body is under motion only by means of rotation. Clear? So if you want to study the concept of rotation, two important things you have to consider. What are the two important things? First of all, you have to consider a rigid body. That means you have to consider one solid body. And the second point, you have to consider an axis of rotation based on the fixed axis. So your axis should not change. Your axis will not be moved left hand side, right hand side, or upside and downside. So you have to make your axis perfectly fixed. So based on that fixed axis, your entire body will be rotating based on the axis. For example, the good example, I can just give you our earth. Our earth is rotating about the axis of rotation. Am I right? That's what we are just frequently getting day and night. So based on the axis of rotating, the earth is not only rotating the sun, it will be first of all rotating the sun as well as it is rotating by itself. So there may be some axis of rotation. That's what our earth is rotating about the fixed axis. There may be some axis. So if any body is under rotation, you must need some axis. That information is given in the slide. Understand?
Doctors, the rotate, it's just for x-axis or all axis?
And no, if you just, for example, in this diagram, we are just giving in terms of x-axis and y-axis. So, and also my axis of rotation here is z-axis. Am I right? You can see the diagram. I can just remove all these things. You can see the diagram. The object is rotating in x and y axis. And what is your axis of rotation? What is your axis of rotation?
Z-axis.
The z-axis. That means that this slide gives you the information about the three-dimensional point of view. Okay.
But the move just for z-axis, right here?
No, here we fix. For example, you can fix your axis of rotation based on x-axis also. So if you fix one axis of rotation as your fixer, and the object will be moving to the remaining axis. So here, according to the diagram, my entire body is rotating about the axis of rotation in z-axis direction, but my body is rotating xy direction.
Okay, thank you, doctor.
Okay. Now let's come for the second slide. The same information is given here, but here we are going to study the new concept of angular position. Further, in chapter number 2, we studied the position. What we mentioned for the position? We mentioned the position as x1 and x2. Am I right?
Yes.
So here we are going to study, if any object is rotating, you can just see we are going to study we are just going to study the concept of these rotational variables by means of theta. So here in terms of rotation, we are going to study the position in terms of theta 1 and theta 2. What is theta 1 and theta 2? The theta 1 and theta 2 represent the angular position of a body about the fixed line. Here. So in chapter number 2, we studied x1 and x2 for the position parameter, but in this chapter we are going to study our theta 1 and theta 2 is for your angular position. This is linear position, this is angular position. So you can see here the object is rotating with respect to some angle. That angle is nothing but here position, because the object is under rotation. Clear?
Clear.
Now let's come for this slide. When any object is rotating, first of all, we have to consider the degree, because it is rotating by means of degree. So initially, we have to consider the measure using radian. So if you want to convert the radian to degree, means you have to multiply by 2 pi. Suppose if you have any values, if you want to consider, because if any object is under rotation, you have 4 quadrants. Am I right? 0 quadrant, 90, 270, 360, and it comes to 0. So if you just see this rotation, the rotation of the body undergoes 4 quadrants, that means 360 degree. So if you want to convert from radian to degree, what you have to do? You have to multiply by 2 pi. So here the radian is a dimensionless. That means it is no unit. Understand? So here, if you just see the displacement, compare the formula from chapter number 2. What is the formula for displacement in chapter number 2? We studied the displacement of chapter number 2 is as x2 minus x1. Am I right?
Yes.
So here we are going to study the displacement as theta 2 minus theta 1. Clear?
Doctor, here theta does not mean the angles.
No. Here the theta represented the position.
Okay.
Clear? It's not an angle. It's a position.
Position.
Now you can see now you can see this diagram. A disk is rotating. Initially, I have the reference point. So this is my starting point of the rotation. Initially, the object is start rotating, and it occupies the direction of it occupies the position of theta 0. Am I right? Am I right or not?
Yes, you're right.
And after that, it comes to this point. Now you can see my initial position is theta naught, and my final position is theta. So what is my displacement? My displacement is theta minus theta naught. Right? That information is given here. So you have to be very, very careful. If you are just strong in chapter number 2, you can directly apply the same formula, but you have to only replace the parameter. In chapter number 2, we are using x1 and x2 for indicating the position of an object. But here we are going to replace this x1 and x2 by means of theta and theta naught. Clear? Yes, brother. I think someone you raise your hand. Is there any question?
Someone said, please, doctors, slowly. He said.
Okay. Brother, I'm going very slowly. Right now, still we are only in second slide. Am I right? I'm just moving the slides very slowly.
Okay, thank you.
Yeah. Better I can just see the video. I think I already recorded the video. Yes, it's recording. My dear brother, please listen carefully. I'm not going that much fast. I'm just moving the slides very slowly. If everybody you are just saying fast, fast means how I can just finish my lecture. We have only 3 periods in a week. And I'm just moving very slowly. I'm just recalling your previous chapter and then I'm just comparing your previous chapter with this chapter. Understand? Please listen carefully. Don't be in the sleeping mood. Understand, brother?
Yes.
Please listen because I'm just moving the slides very slowly. If everybody is saying fast means how I can just go. I'm just going very slowly only. And whenever I take the problem question, I'm just going very slow. I'm just explaining step by step. And nobody will ask the question. You're just simply sitting and simply saying fast, fast, fast. Is anyone asking the question during my lecture? Nobody. Only 1 or 2. I have 28 students in this lecture, in this class. Out of these 28 students, only 1 or 2 students they are asking the question. Remaining students, you are just simply saying, teacher, you are going very fast. Okay, if you have any question, after each and every slide, I ask you the question. Why you are not opening your mouth? You get my point?
Yes, teacher.
Please, each and every slide, I'm asking you the question. If you have any question, please raise your question. I'm here to help you, brother. Okay. So you can just see this disc. This disc is about rotation, about the axis of rotation. What is our axis of rotation? This is our axis of rotation, this dotted line. Now the disc is about to start rotating in the anti-clockwise direction. What is anti-clockwise direction? This is going in this direction. Clockwise direction is this direction. So now, based on this diagram, my disc is rotating in the anti-clockwise direction. So initially I have the reference point. So this is my starting point. Reference point is nothing but our starting point. That means based on this line, my object is start to rotate. Now you can see after the body start to rotate, it's reached this point. What is this point? This point is nothing but from the reference point to this point. What is my position? Theta naught. And after some time, from this point, based on the reference point to this point, I have another position theta. Now I have to find what is the displacement of the object. What is the displacement of the object? The displacement is nothing but delta theta, which is equal to my final position.
Theta.
What is my final position from the diagram? Theta. What is my initial position? Theta naught.
Theta naught.
Clear?
Doctors.
Yes.
Clear. Doctors, here axis of rotation is Z, right?
Yeah, of course. You can take any axis, brother. If you just make one axis of rotation, then the object will be rotating in the remaining axis.
Okay. About theta, it's degree when we put the.
Actually, brother, in the question we will give the answer. For example, if the question have the information about the radian, for sure you have to convert that radian into degree. So how you have to convert the radian to degree? If you multiply by 2 pi value, then you will get the answer. Clear?
Okay. Clear.
So here you can see I have the values in terms of radian. What is my radian? Radian 2 pi, which is equal to how many degree? 360 degree. Maybe 1 mark theory question. My radian pi is exactly equal to 180 degree. My radian pi by 2 is exactly equal to 90 degree. If my radian is exactly 1, I got 57.3. Where we got? For example, you can see 1 multiplied by 360 degree divided by 2 pi. So if you just multiply, what you will get? 57.3 degree. Clear, brother? Understand? Yes.
Clear.
Theta naught, is it always the reference point or what?
No, from the reference to where the object is initially going. For example, brother, you can see I am just walking. For example, here I have a tree. I'm just explaining the concept from chapter number 2. Here I have a tree. Right now, my reference point is tree, 0. Okay. Now I am standing exactly in the position of the tree. Now after some times, I'm just reaching this position. I'm reaching this position. Now you can see this is my 5 meter. Now you can see what is my displacement. My displacement is nothing but final position minus initial position. What is my initial position? My initial position is based on the reference. Am I right?
Yes.
So now you can see x2 minus 1. What is my x2? 5 is my x2. x1 is 0. So finally, what is my displacement? 5 meter. Likewise, here initially the object is at the reference point. After some times it reached the point this, and what is the distance covered? It is nothing but theta naught. And after some times the object comes and take position in this location, and now this location from the reference point is theta. So what is my displacement? Angular displacement. Final angular position minus initial angular position. Clear?
Yes, Doctor. Asking about the initial.
Initial is always starting from the reference.
Yeah, okay.
From the reference to where the object is going to rest. Because reference point, every time when you are studying the concept of motion, you have to consider some reference point. Based on the reference point, you have to give the answer. Clear?
Yes, clear now. Thank you.
Okay. Now, let's come for the right hand rule. So here, how to find the direction of the angular velocity? Because angular velocity is a vector quantity. How we have to use? For example, you can see this diagram. So you just hold this rod, and your rod is rotating in the anti-clockwise direction. So what you have to do? You have to hold your right hand like this, and your thumb indicates the direction of the angular velocity. So sometimes we will ask one more theory question: how to find the direction of the angular velocity? You have to write by using the right hand rule. So your thumb indicates the direction of the angular velocity. So this is the direction of my angular velocity. In chapter number 2, we are just using the velocity by means of v. Am I right? Am I right?
Yes, yes.
So in this chapter, we are going to use the velocity in terms of angular velocity. It should be written as omega. Omega is the angular velocity. So here we are
Omega
just
is
using omega is the angular velocity. So the how you have to represent this angular velocity by means of omega. Omega is the angular velocity. It's a vector quantity. Clear?
Okay, clear.
Okay, you can see here, brother. I just give all the information. Theta, omega, alpha. What is theta? Theta is my position. Omega is the velocity, and alpha is the acceleration. In chapter number 2,
Yes.
in chapter number 2, we are using the position as x, velocity as v, acceleration as a. Am I right? But in chapter
Yes.
rotation, we have to replace this x with theta. We have to replace this velocity v by omega. And we have to replace the acceleration with alpha. Remaining all the concepts are exactly the same what you studied in from chapter 2. Okay?
Yes. Okay.
Okay. Now you can see the slide. You can compare your linear motion with the angular motion. Linear motion, chapter number 2. Angular motion, chapter number 10. You can see this diagram. You can just compare the formula. In chapter number 2, we are just having the formula for angular displacement as delta x, which is nothing but x2 minus x1. Am I right?
Yes,
Means
you're right.
final position minus initial position. But here, in terms of angular, you have to write final position theta f minus initial position theta I. And in chapter number 2, we are using this velocity as x2 minus x1 over t2 minus t1. Am I right? So now, in terms of angular speed, what you have to do? My final position is theta f. My initial position is theta I divided by time final minus t initial. So how you can write? This is my angular displacement. This is my change in time. So in chapter number 2, we are just using the formula like this. Am I right?
Yes, you're right. Doctors,
Yes.
why here they write average angle speed? They should write average angle velocity, because we know the speed is total position.
Okay, you can just write like this.
Yeah.
Exactly.
Here it means speed velocity, right?
No. Actually, here we have to write velocity. Okay, but angular speed also you have. If you take the magnitude of the angular velocity, you will get angular speed. All right.
Yeah, because the speed
Okay.
is for total position, right?
total position, and here we are dealing with the rotation. If any object is under rotation, you have the same position. Am I right?
Yes, you're right.
Okay. Likewise, angular speed, that means you can write this is instantaneous angular velocity. So we already studied this rule in chapter number 2 as v vector, which is nothing but dx over dt, and here we are using d theta over dt. So if you are strong in chapter number 2, studying from chapter number 10 will be very easy. And likewise, in chapter number 2, we are studying the acceleration. What is the formula for acceleration? V2 minus V1 over T2 minus T1. So here we have to write delta V over delta T in chapter number 2. Am I right? But here we have to write V2 as omega 2, V1 as omega 1. So I have to write delta omega over delta T. Exactly same. And in chapter number 2, we studied the instantaneous acceleration. What is the formula for instantaneous acceleration? dv over dt. Am I right? But here it is d omega over dt. So whatever the things you studied there, it's exactly same. But only you have to replace the parameter. Brother, please don't write the formula as exactly chapter number 2. If the question is related with the rotation, then you have to replace all the parameters in terms of rotation. Clear?
Okay, thank you, doctors.
Okay. Now let's come for the 5 equation. We already studied this 5 equations, but I think one equation is missing here. But these 3 equations are very important. Very important. First equation, second equation, third equation. Right? So you can see this is our equation in linear motion, and this is the equation for angular, that means rotational motion. And here we have v final. This is v initial, acceleration t. Just before I told you v final, how you have to write omega f. Right?
Yes.
And initial it is omega I, and acceleration we have to replace a with alpha. Time as it is t. You can see everything is written like this. So if you are strong in chapter number 2 equation, only important thing you have to replace x with theta, b with omega, and a with alpha. If you just replace everything, you will have the same equation what you studied in chapter number 2. I don't want to waste the time in this slide because we already studied the equation based on linear motion. And if you
Very
just
easy, doctors.
everything is same. Only important thing you have to replace the parameter. Understand?
Understand, doctors.
Okay. Now let's come for the relation between the angular position and the linear position. So in angular position, we are just explaining with x. Am I right? Linear position, it's theta. Am I right or not? Angular position is theta, linear position is x. What is the relation between these two? So if you just see this diagram, brother, you can just see this diagram. I have an object. Initially, the object is at the location P. And after some time, the object comes and accommodate the position Q. So what is the distance travel? The distance travel is exactly, what is the distance travel from point P to Q?
Yes.
Yes. So based on from this point P to Q, the object is exactly traveling a distance, yes, with respect to some angle theta. Am I right? So here, so we have to study the relation. What is the relation between these positions? So here my position based on the diagram is yes. So we already studied the formula arc length in mathematics. So you have to use that mathematical formula by using arc length. Have you studied this formula in mathematics?
Yes. We know the.
What is the formula for arc length? So the distance s, which is equal to r multiplied by theta. For example, if any body is rotating, this is our radius. Am I right? What is this?
Yes, you are right.
This is my radius. This is my radius. This is my radius. So you can see our radius is common whenever the object is under the circular motion. Now you can see how much distance this object is travel. The object is travel s distance. And what is its length? The distance from the center of origin to the point is exactly r. So we have to write the distance travel, which is nothing but the radius multiplied by theta. So from this, you can just write my theta, which is equal to s over r. So here what I used, I'm just using the formula of arc length you already studied in mathematics. So this is the relation. Sometimes we will ask the question, write the relation between the linear position and the angular position. The linear position is exactly yes. The angular position is exactly theta. So what is the difference? When you just multiply the 3 with the theta or with theta, then you will get the linear position. So it's a 1 mark theory question.
Doctor, can you say again, please? You
Brother?
said the relation between.
Brother, in chapter number 2, we studied the position as x. Am I right?
Yes.
And here we studied the position as theta. Am I right?
Yes, you're right.
Now, what is the relation between these two? The relation between these two is nothing but when you just multiply with the radius with the theta, you will get the relation. So this is my linear position. This is my angular position. Clear?
Just I mentioned the equation, right?
The equation is enough. Equation enough. But according to the diagram, my position is this x is written as yes. Am I right?
Yes, yeah, you are right.
So I can just write s, which is equal to r multiplied by theta.
The relation is just multiply with r, right?
Yes, every time we have to multiply with r because the object is under rotation. Okay, likewise, let's come for the same concept for relation between linear speed and the angular speed. So linear speed is v, my angular speed is omega. If you multiply with r with omega, you will get the relation. So how we got? We know the formula from chapter number 2, v which is equal to dx over dt. Am I right? We already studied this formula. Am I right? Now, from this point, for example, you can consider from this point to this point, the object covers the distance yes. Okay? So I can just write this x as yes. Am I right?
Yes, you are right.
And in the previous slide, we studied the relation. What is the formula for yes? S which is equal to r theta. So I am going to take this answer. I am going to substitute here. So yes, which is equal to r theta. Now substitute here. When you substitute here, I will get like this. Am I right?
Yes, you are right.
And our radius is common, so I take it outside because it's a constant value. When any object is under rotation, your radius is constant, am I right? So I take the radius outside, so I can write r multiplied by d theta over dt. What is this d theta over dt? Just before we studied, which is nothing but angular velocity. So I have to write which is equal to r multiplied by omega, left hand side is
omega.
So,
it's here velocity.
Angular velocity. It's not a velocity, angular velocity.
Angular velocity. What's possible, teacher? Velocity with the angle velocity here.
Brother, this is a linear velocity. This is
linear. I know that.
Linear velocity. This is angular. If any body is rotating, then you have to use this word angular. Okay.
Yes. Okay.
This entire chapter we are going to study the concept of
like x, but they mentioned s. Right?
yes.
Yes. Okay. Clear.
Now let's come for acceleration. We already know the formula for acceleration, tangential acceleration. Brother, what is the formula for acceleration? We studied this formula in chapter number 2, dv over dt. Now I am going to take this v from the previous slide. What is our v? Our v is r omega. Am I right? Am I right?
Yes, you're right.
So I am going to write it here. My v which is equal to r omega. Now I am going to take and substitute here. If you substitute, what you get? My a which is equal to d of r omega over dt. Am I right? And our radius is common, constant value. So I take it outside. So what you get? R multiplied by d omega over dt. What is d omega over dt?
Theta.
Alpha. This is angular acceleration. So we have a relation connecting linear and acceleration based on position s which is equal to r theta, based on velocity e which is equal to r omega, based on acceleration a which is equal to r alpha. Clear? Please, brother, don't forget this equation. This equation is very important in chapter number 10.
Doctor, should we know how it's coming, the equation?
No need, because if you just because we are going to use the formula only in the problems. Okay. But keep the formula always in your mind.
Teacher, dv over means delta or
brother here we are using instantaneous.
okay, instantaneous. Yes.
It is instantaneous acceleration. Okay.
Yes.
Okay. Now let's become for the radial acceleration. Whatever the things we studied is tangential. What is my tangential, brother? You can see the diagram. If the object is rotating, this is our tangential. Am I right? When you just draw a tangential, this is our tangential. Am I right? Am I right or not?
You're right.
Now what we are going to study? Now we are going to study this direction. What is our radial acceleration? So that information is given here. We studied this formula in chapter number 4 and chapter number 6. Radial acceleration. What is radial acceleration? V square over R. Am I right?
Yes, we studied that.
Now we know the formula for V. What is V? V which is equal to R omega. Am I right?
Yes, you're
Also,
right.
take this value and substitute here. So what you will get? Which is equal to R square omega square over R. Am I right?
R cancel with R.
R cancel with R. Finally, what you will get? You will get radial acceleration, which is equal to omega square multiplied by R. So, brother, you can just see from this chapter, whatever the things we studied in the previous chapter, we are taking and we are just connecting with this chapter. Am I right?
It's very easy, doctor.
It's very easy, but brother, sometimes you will say like this, but you will just do mistake when the question came. So please read the question and try to substitute the formula very carefully. Okay?
Doctor, here A1, what's mean? AR here mean, right?
AR is nothing but the centripetal acceleration.
Okay.
So this is your centripetal, the tangential acceleration. This is your centripetal acceleration. Always your tangential acceleration is perpendicular to your centripetal acceleration. Keep this point in your mind.
Okay.
And you have two formulas. This is my centripetal acceleration for the rotational body. What is my tangential acceleration? R alpha. So my tangential acceleration is nothing but R alpha. My centripetal acceleration is omega square multiplied by R. So, brother, if you have any question, read the question. What is given here, what they need, just read it and apply the rule.
Okay, clear, doctor.
Okay. Now, let's come for the topic of moment of inertia. Brother, this is one of the important topic, and inshallah, this week, we are going to do this experiment, moment of inertia. Brother, moment of inertia of any object depends on 3 parameters. What is this? What are the 3 parameters? It must have some axis. So if any body is rotating, it must need some axis. And the second thing, the object must need some mass. And the third important thing, there must be some distance between the axis of rotation as well as the mass. For example, you can see here, I have an object. This is my axis of rotation. Consider this is my object. And here I have an object. And in this, the object is rotating. And this is my axis of rotation. Now you can see, this is the distance between the axis of rotation and the mass. Am I right?
Yes, you're right.
So my distance between the axis of rotation is nothing but R, and this object have some mass m, and this is my axis of rotation in this direction, anti-clockwise direction. Now you can see, brother, if you take a big body, that means some big rigid body, and this big rigid body is made up of small particles. Am I right?
Yes, you're right.
Now you can see this is my axis of rotation, and each and every particle has mass. Am I right?
Yes, of course.
And each and every particle has its distance. Am I right?
Yes.
This object has this much distance. This object has this much distance from the axis of rotation. This object has this much distance from the axis of rotation. Now, how you can write the moment of inertia? Moment of inertia for each and every object. So, suppose I can write m1 r1 plus m2 r2 plus m3 r3. So, here each and every small particle is m1, m2, m3, and each and every particle has some distance from the axis of rotation. So, I can write the formula like this. In general formula, I can write I which is equal to what is this? I which is equal to summation of I tends to 1 to n mi ri. Clear? And the most important thing, square of the distance. Clear? So, what, brother?
Why we put square of R?
No, this is the rule, formula. Square of the distance from the axis of rotation to the mass.
Okay. Doctor, for a moment, why we don't mention the time? I think it's depends also on the time.
Moment of inertia, and later on it will be cancelled. Inshallah, you will get the information from the practical. When you're just doing this practical, this experiment in the practical class, you will get some clear picture about the time. Clear?
Okay, good.
So the time parameter will gone later on.
Teacher,
Just rotation.
Just rotation, because we are talking about the rotation based on the object and the axis of rotation.
Okay.
Okay. Now we know the kinetic energy. Am I right? What is the formula for kinetic energy, brother? What is the formula for
mv square?
Half mv square. Am I right? Okay. If you are applying this kinetic energy for any object under rotational, how you have to write? Kinetic energy based on rotation is equal to, you have to write same half, and in place of mass you have to write the moment of inertia. In place of velocity you have to write omega. So if you're strong in kinetic energy formula, you can derive the formula for the rotation also.
Doctors, it's here mass, like mass.
Brother, I can write. What is x here? The x is theta. Am I right?
Yes, you're right.
What is v? V is omega. Am I right?
Yes.
And what is acceleration? Acceleration is alpha. If you have mass, what mass always deals with moment of inertia, I. Clear? Clear? So, and we know v is nothing but omega square. So if you write the kinetic energy formula, we know half mv square. Now if you replace m with I, if you replace v with omega, then you will get this formula.
Okay, clear. About the second equation, it's here mean mass.
I is nothing but our moment of inertia. Moment of inertia is nothing but mass multiplied by its radius square.
Doctor, so 1 minute. Here it's mean moment, right? B.
Brother, listen carefully. This is my axis of rotation, and here I have one object, okay, and this object is under rotation like this, okay. Now you can see from this object to the axis of rotation, it has some distance. Am I right?
Yes, you're right. We have
and you can see this object have some mass. Am I right?
Yes, you're right.
So if you want to write the moment of inertia formula, mass multiplied by the square of the distance from the axis of rotation to the mass. So what is my distance between the axis of rotation and the place of the mass? It is nothing but r. So it's a square of the distance of the.
Okay, I know that. About the I here.
I is the moment of inertia. I is nothing but
moment. Here we mentioned like the moment, but
moment of inertia. For example, define moment of inertia. One mark here question. What you have to do? Write the formula. I, which is equal to m r square. I is the moment of inertia. M is the mass of the object. R is the square of the distance from the axis of rotation to the mass.
And we should write sigma for this equation.
No need to write sigma. Brother, listen carefully. If we ask definition, no need to put sigma, because why we put sigma? For example, if you have a big body, big rigid body, and this big rigid body is made up of small particles. Am I right?
Yes, of course.
Suppose you can consider this is m1, this is m2, this is m3, and if this is my axis of rotation. So the collection of these small particles form the big one. Am I right?
Have radius, yeah.
So then only we have to put sigma. But in definition question, no need to put sigma. Just write the formula I, which is equal to mi or I square or m r square.
Here, doctors.
Teacher, every r with the square.
For the moment of inertia, this is the distance from the axis of rotation to the mass square. Okay, that is nothing but r.
Okay. Likewise, if you're just using the same rotation, because we already know the formula for kinetic energy. What is the formula for kinetic energy? We know kinetic energy formula for the linear is nothing but half mv square. Suppose if you have any object, some big object, this object is made up of small particles.
When you apply this kinetic energy for each and every object has this value. Am I right? Half mv square, half mv square, half mv square for each and every object. Now I'm going to replace this v with r square omega because we already studied the relation. What is v? What is m? Am I right? Just before I told you, you have to replace m with I. You have to replace v with omega. Am I right?
Yes, you're right.
If you just apply this rule here, and finally I got these things. So the moment of the kinetic energy for all this object, which is nothing but kr, kinetic energy rotation, which is nothing but summation of half I omega square, half I. So I tends to 1 to n.
Doctors, here in this slide, they mention how it's coming the kinetic energy, right?
Yes. The explanation is given. The explanation is given here. How we got a half I omega square.
Clear.
Clear, brother.
They mention difficult, you know.
My dear, listen.
How it's coming.
My dear, listen here. Take the shortest way to read the concept in physics. Don't try to memorize all these things. If you just strong in one formula, keep that formula as your reference, and then please derive the formula from the reference. Okay?
Yes. Okay.
What is our reference? Based on this chapter, our reference is chapter number 2. Am I right? Whatever the formulas you studied in chapter number 2, we are exactly applying all these things here. Am I right or not?
Yes, you're right. And we should.
Please study because okay. Let me come for this question. What is given in the question? This question is for you. We know the formula for moment of inertia. What is the formula for moment of inertia?
I,
which is equal
multiply.
to r m r square. Am I right?
Yes, you are right.
Okay, you can see here how many masses are given. Here mass 1, big body, mass 2 is small, mass 3 is big, and mass 4 is small. Am I right?
Yes, you are right.
Now you can see the diagram is given in terms of x-axis and y-axis, and you have another axis z also. Am I right?
Yes, you're right.
Okay, now could you please read the question? 4 small spheres are mounted on the corner of the frame. What are the 4 small spheres? Mass 1, mass 2, mass 3, mass 4. So it is connected at the corner of the axis. Am I right or not?
Yes, you're right.
What is the rotational energy of the system if it is rotated about the z-axis? So you can see all these 4 masses is rotating about the axis of z. Now how you have to write? We know the formula. What is our formula, brother, for the kinetic energy? Kinetic energy rotational, which is equal to half I omega square. Am I right?
Yes, you are right, doctor. Yes.
So I'm going to use this formula. Okay, now the object is rotating based on z-axis. Brother, listen carefully. This question is very, very important. If all these 4 bodies rotating about this z-axis, what are the remaining axes?
Z-axis.
Wait. I can just put one more page, then I will explain this question. Okay. Now, mass 1, what is the diagram? Mass 1, mass 2, mass 3, mass 4. Okay, this is my mass 1, mass 2, mass 3, mass 4. Am I right? We know the kinetic energy for the rotation. What is the kinetic energy for the rotation? Half I omega square. And what they mentioned, all this object is rotating in your z-axis. Am I right?
Yes, you're right.
So now, if all this object is rotating in terms of z-axis, so you have to consider x-axis and y-axis for the rotation. Am I right or not? So you have 3 axes: x-axis, y-axis, z-axis. Now, if this object, if this entire body is rotating about your z-axis, what are the remaining 2 axes are under rotation? Your remaining 2 axes under rotation is nothing but x and y. Am I right?
Yes.
What is your axis of rotation? My axis of rotation is z-axis.
Z-axis, yes, of course.
So now, how I can write? I can write the formula by kinetic energy rotation based on z-axis, which is nothing but half I omega square for x-axis plus half I omega square for y-axis. Am I right?
Square. Why we didn't mention the square of omega?
Okay. Okay.
Okay.
Clear? Okay. Now we know the formula half I omega square. Now how to find this I? We know the formula
For the formula.
m
Yeah.
r square. Am I right?
Yes, you're right.
And you can see the question. Mass is given here. And my A value, B value is given. What is my A? My A is the distance from the axis of rotation. Am I right? So what is my distance? A is my distance and B is my distance. Am I right? And the value is given here. So how you have to write? You have to write this answer. The answer for this question is nothing but kinetic energy based on rotation for z-axis, which is nothing but half I omega 1 square plus a half I omega 2 square. Am I right?
Yeah.
So now
Yes, you're right.
half I is nothing but m r, so that m1 r1 square plus half m2, sorry,
You must
wait,
omega.
I forget. Omega, I forget. It is equal to half. What is I? My I is nothing but m1 r1 square multiplied by omega I square. Am I right? Plus half m2 r2
Square.
omega square
R square.
half
R square.
sorry, half m3 r3 square omega square plus half m4 r4 square omega square. Am I right?
Omega square.
Am I right? Now you can
Yes,
see
you're right.
mass value is given in the question. What is your r from m1? My r1 is nothing but a. Am I right?
Yes.
And when you come for the second mass, my mass 2 has some value. What is my r? It's b. Am I right?
Yes.
Likewise, you have to substitute the value, get the answer. All these informations are given here. Your omega value is given. What is your omega value? Your omega value is 5. Am I right?
Yes. They mention vertically.
So
Yeah.
in this question, all this info. So if you just extend this question, half m1 a1 square omega square plus half m2.
Doctors, why you change R to A?
Because from r1 is nothing but my a here.
Yeah. Yes.
And here my r2 is nothing but b. Am I right?
Yes, you're right.
My r3 is nothing but a.
Yeah.
My r4 is nothing but b. So I have to write here. Plus half m3 a square multiplied by omega square plus half m4 b square omega square. Now substitute all the value, you will get the answer. Okay.
Okay. Clear, doctors.
So likewise, you have to answer.
M1 and M3 same, right?
Because here they give the value. The capital M has the value of 5. That means these two objects are 5 kilogram. These two objects are 5 kilogram, and these two objects are 2 kilogram. Clear?
And also they mentioned the radius.
Yes, A
1.5
value,
meter.
A value, B value. So what is the value of A? A value is 1.5, B value is
1 meter. Clear, doctor. Thank you.
Clear? So likewise, you have to answer for the second question. The first question related with the axis of rotation is z-axis. But what is your second question?
What's the Yes.
Only y-axis. Now what should you answer, brother? You can see you should not consider your
Yes,
y-axis. This is your axis of rotation, right?
Yes.
So you should not consider, only you have to consider M1 and M3.
Doctor,
What is it? Yes.
it's not y-axis. We just mentioned the y-axis.
Brother, this is your axis of rotation. If this object is rotated under your y-axis, the remaining axes are rotating. Am I right? Brother, first question, z-axis is your rotation. Am I right?
Yes, you're right.
Your z-axis is your axis. Listen. First of all, listen here. Your z-axis is your axis of rotation. So your x and y will rotate. Am I right? Now, what is your axis of rotation? Y-axis is your rotation. So what are the remaining two axes rotating? X and Z will rotating. Am I right?
Yes, you're right.
So in this diagram, Z-axis information is not given. So forget about that. Only X-axis will rotating.
Okay.
Clear? So in such a way, we will ask the question from this chapter. So you should be very, very careful. Clear?
Here, doctor.
Okay. Now, brother, this moment of inertia for different axes of rotation, we have some formula. Don't worry about this formula. We will give the formula for different object. Clear? So no need to memorize these things. This formula will be given. If any question is related with, for example, you can see this diagram, brother. You can see this diagram. I have the same structure. Am I right? You can see all the objects have same structure. Am I right?
Yes.
But you can see the axis of rotation. Here, my axis of rotation is exactly passing through the center of the object. Am I right? And here, my axis of rotation is only at the end of the object. Am I right?
Yes, you're right.
And here, my axis of rotation is exactly passing through the center of the object. So each and every object, there is different formula. If my axis of rotation will be like this, this will be the formula. If my axis of rotation will be like this, then this will be the formula. So don't worry about the formula for different object and different axis of rotation. This formula we will give. But the general formula for this moment of inertia, you have to memorize. What is our general formula for the moment of inertia? The general formula for the moment of inertia is nothing but m r square. So please keep this formula in your mind. Understand?
Okay. How about here limits?
And we will give this information. Don't worry. We will give this formula.
No,
If the question is,
I mean here.
forget about that. This is by using this formula, brother. Listen carefully. By using this rule, we got all this. We got all this formula. So no need to worry about this rule. Okay, this rule we are not going to use this rule for solving the problem.
Alhamdulillah.
Okay, so don't worry about this formula. Only you have to give the concentration for the basic formula for the moment of inertia. Okay. Now, this is our last slide. What is torque? For example, what is given here? I just give the picture of door as well as this cat coming out of this entrance. Brother, if you want to open this door, where you are going to put your hand? If you are using your hand here, you can easily open the door very quickly. Am I right?
Yes.
If you are just pushing the door from this point of view, you can open the door. It will be a little bit harder. Am I right?
Yes, you're right.
So our axis of rotation will be here. Am I right or not? Our axis of rotation will be here. Am I right?
Yes, you're right.
So when you put your hand to the distance, for example, what you have to understand from here, where you are going to apply the force and where is the axis of rotation, the distance. If the distance will be more, then the rotation will be very easy. For example, this is my axis of rotation.
We studied that in high school.
Yes. For example, this is your door. And you can see here we fix the door to the wall. Am I right?
Yeah.
Now here I have a lock. So I want to open the door means from the axis. So this is our axis of rotation and this is the distance r. Am I right? So if your r will be more, you can easily apply the force in this point. You can easily rotate this door. Am I right?
Yes. You're right.
So suppose if I place the handle here, what will happen?
It's not like when we go far.
Yes. So if you put your handle here, you can open the door, but it will be a little bit harder. So if you want to study the concept of torque, you must need the applied force and the distance r. applied force is nothing but F, my distance is R. So here you are going to apply the force and here your R value. So we are going to study this rule. You can see this diagram. You can see this this instrument. Suppose if you want to open this valve means you have to use this type of rod. Am I right? You can see this is my, in this place you are going to apply the force. And what is the axis of rotation? My axis of rotation is R. Am I right?
Yes, you are right.
And likewise, you can see if you want to remove the tire, this is your axis of rotation. So this is your R value. And here you are going to apply the force perpendicular. So my force perpendicular is exactly applicable for the R value. Now you can see what is the angle here. What is the angle here?
90.
90 degrees. So if you want to put 90 degree, how you can write the formula? We already studied this formula in chapter number 3. You can see in this direction you are going to apply the force. In this direction you are going to apply the force. Am I right?
Perpendicular with the
Now
radius.
this is my R. So this is my force. Now what is the angle? It's exactly 90 degrees. So how you can write the torque formula? My torque should be indicated with the letter tau, which is nothing but R cross F. What is R cross F? We studied in chapter number 3. R cross F is nothing but RF sine theta, because if you put theta as 90 degree, then you will get the maximum torque. Am I right?
Yes.
Where we studied, where we got this formula? Could you please recall the formula from chapter number 3? A cross B. What is the formula for A cross B? AB
Sine theta.
sine theta. So likewise R cross F is nothing but R of sine theta.
Okay. Clear, doctor.
Clear? And that information is given here. So here by distance. So R is nothing but here. You can see my R is nothing but here D. So this is my R. Am I right?
Yes.
And I am just applying the force. So in this direction, I am going to apply the force. So you can see what is my angle here. My angle is exactly
90.
90 degrees. So my torque tau, which is equal to R cross D, according to this diagram. So how I can write? R D sine theta. What is my theta? My theta is 90 degree. So I will get, sorry. I just write the formula wrong. So torque tau, which is nothing but F cross D, which is nothing but FD sine theta. Theta is 90 degree. So I will get FD. This is my applied force. This is my distance from the axis of rotation to my applied force. So this is my distance. Yeah.
Clear, doctor. Always sine, right?
What, brother?
I said always here sine because the perpendicular with the D.
Yes.
And,
Because brother, here the sign is exactly 90 degree. If you apply the force 90 degree, you will get the maximum torque.
yes.
Okay. Now you can see, brother, in this slide you have 1 mark theory question. Brother, if your torque will be exactly anti-clockwise direction, your torque will be positive. Okay.
Yes.
If your applied torque will be exactly in the clockwise direction, the value for this tau is negative. This is 1 mark theory question.
Okay.
Clear? If it is clockwise direction, the torque will have negative value. If the object is moving in the anti-clockwise direction, your torque will be positive, because we have one question based on this concept. This is the theoretical concept. Clear?
Clear, doctors.
Okay. Could you please recall the formula? I think our chapter is over. Oh, one more important thing is there. Okay. Let's finish this. What is the relation? Brother, what is the relation between the torque and the angular acceleration? Because torque should be indicated with the letter tau, and the acceleration should be indicated with the letter alpha. Am I right?
Yes, you're right.
Okay. Now, what is the relation? You can see this slide. We know the formula for torque just before we studied. What is the formula for torque? My formula for torque, which is nothing but RF sine theta. Am I right?
Yes.
And if you put 90 degree, I will get RF. Am I right?
Yes.
My force is nothing but the tangential force. Am I right or not? Now we know the Newton's second law. What is Newton's second law? The Newton's second law is nothing but MA. Am I right? Take this and substitute here. If you substitute here, you will get this. Am I right?
Yes, you're right.
And we studied this formula. What is our tangential acceleration? R alpha. Am I right? Now take this value, substitute here. You will get this. Am I right?
Yes, you're right.
Now what is this? mr square. My mr square is nothing but moment of inertia.
Yes.
So how I can write? My torque, which is nothing but, this is nothing but my I and alpha. So this is your relation connecting torque and the acceleration.
Okay, clear.
Clear?
Doctor, before this slide, we have
This one.
before this is a slide.
Ah.
Have f cosine theta and
No. Here there is no cosine, because if you put 90 degree for the cosine, what should be the answer?
No, I mean in the slide before this slide.
Which
See?
slide you are saying?
Yeah, yes, I mean here.
Okay.
Yeah, we have f sine theta and f cosine theta.
Brother,
Oh, if
always.
you-
Okay. You are talking about this diagram. Am I right?
Yeah.
Okay.
Yeah,
Now
this
you can
diagram.
see, brother. You can see here. You have x component and y component.
Yeah.
So here the object, every time the object is considered. For example, you are applying the force perpendicular. Am I right?
Yes, you're right.
So what should be the value of cosine?
90.
Because you are not applying any force in this cosine direction. You are applying the force only in the
Zero.
sine direction. Am I right?
Yes. It's,
So-
here will come 0.
So this cosine will not work here. Only the sine will work here.
Yes, of course. Okay.
Clear?
When we have angles, it's work, right?
What, brother?
If we have angles,
Okay.
no, 90 degree, maybe
90
30.
degree, 70 degree, 60 degree, whatever the angle we give, just substitute in this rule.
Sine.
Sine, yeah, you have to consider only sine, because there is no force in the cosine direction. So according to this diagram, this cosine will not work.
Yes, okay.
Only the sine will work.
Okay.
Clear?
Clear.
Okay. Now we are going to summarize all these things. Brother, please listen carefully. All these are summary. Whatever the things we studied before, we are going to compare that formula with the rotation. Sir, what is the formula for work done? What is the formula for work done?
FD.
FD. So here D is nothing but yes. I am just putting D as yes.
Okay.
FD. Now we know the formula. What is my force? My force is nothing but torque. My position is nothing but theta. So in terms of rotation, how you can write? My force is linear force. We have to apply F. For rotational force, it is torque.
Oh, yeah.
And linear, my distance is nothing but yes. Here my distance is nothing but
Theta.
theta. So that is the relation connecting work as well as that. That means this is your linear. This is your linear formula for this linear work. This is for the rotational work.
Doctor, how to come theta and the
Okay. No, I will come for here. What is my formula for work done? This is FD. Am I right?
Yes, you're right.
Okay. For the rotation, I have to replace F with torque tau. Okay.
Okay, but tau it's F multiplied with
My dear, listen carefully. Don't get confused about torque. Torque is the rotational force. Torque is the
rotation.
clear. So whatever the force you are considering for the rotation, it will be related with
tau.
Now, clear. So here, according to this, my applied force linear is FD. So based on the rotation, my applied force is tau, and based on this position, which is nothing but theta. So this is for my linear force. This is for my rotational force. Sorry, linear work, rotational work.
Okay, clear. But
Okay.
here, why
Now-
they mentioned dW?
Where DW?
I mean here, dW. They mean derivative or what?
Where is DW? Just to show me, where is DW?
See the first formula. dW equal to
This one?
F multiplied with
This one?
ds.
This
Yes.
one?
Yeah.
Okay, you can, brother, small force, small work done is dW, small displacement is d theta.
Okay.
So I can write this is my entire entire work done, this is my entire displacement.
Okay, clear.
Okay, now you can consider if any body is under rotation, brother, see this diagram. Brother, you can see here, if any body is under rolling, you have translational kinetic energy as well as rotational kinetic energy. Am I right?
Yes, you're right.
At this point, I have the velocity in this direction, and at this point, my tangential force is this. Now you can see both arrow mark are in the same direction. So my amplitude, my final magnitude is lengthy. Am I right?
Yes, you're right.
Now at the center, I have my linear direction is this direction. When any object is under rotation, at the center there will be no velocity. Now if you add these two, you will get the same. Am I right? Now, when any object is moving translation direction, that means the straight direction, my speed will be in this direction, and based on the rotation, my speed will be in the opposite direction. So one will be in the right hand side, one will be the left hand side. What will be the result?
RW.
Zero.
0, yeah.
So if any body is on rotation, you have both the translational kinetic energy, you have rotational kinetic energy. Translation kinetic energy is written as half mv square. Rotational kinetic energy is written as half I omega square. Clear? And you will study this formula in next chapter. Understand? And then it's a summary. You can see the summary. What is given here? This is our equation of motion with constant acceleration for linear, and all this for the rotation. Clear? We already studied this rule. Now, linear motion, we are using half mv square. Rotational motion, we are using half I omega square. Am I right?
Yes, you're right.
And linear force, we are using Newton's second law, F is equal to ma. In rotational force, we are using torque tau, which is equal to I alpha. Clear?
Clear, Doctor.
In linear momentum, we are using the formula M multiplied by V. Inshallah, you will study this in chapter number 11. And that we are studying the rule L is equal to I omega. And in linear work, we are using the formula F dot D or F dot S. And in the rotational, we are using the work as tau multiplied by theta. Just a comparison. Okay.
Okay.
That's it. So, how many formulas we learned today, brother? Could you please recall the formula? We studied the formula delta theta, which is equal to theta 2 minus theta 1. Am I right? Final position minus initial angular position. Am I right?
Yes, you're right.
Okay. Then acceleration. Sorry, linear speed. What is the formula for linear speed? Linear speed is nothing but
V2 minus V1.
delta theta over delta t. Am I right?
Yes.
What is my
Right.
acceleration? My acceleration is nothing but delta omega over delta t. Am I right?
Yes, you're right.
And instantaneous velocity. What is my instantaneous velocity? It is nothing but d theta over dt. My instantaneous acceleration is nothing but d omega over dt. Am I right?
Yes, you're right.
What is the relation connecting the linear position and the angular position? S, which is equal to r theta. What is the relation connecting linear speed and the angular speed? V, which is equal to r omega. What is the relation connecting the angular acceleration, the linear acceleration? A, which is equal to r alpha. Clear?
Clear, Doctor.
And tangential acceleration, which is equal to, I think I have to see this rule. What is our tangential acceleration? R alpha, sorry, radial acceleration. Omega square multiplied by r. It's radial acceleration. What is our radial acceleration? What is our radial acceleration? R into omega square. And what is the formula for torque? My torque, which is nothing but RF Sine theta.
Sine theta.
And what is the formula for moment of inertia? Moment of inertia I is equal to mr square. What is the formula for kinetic energy for the rotation? Kinetic energy for the rotation is nothing but half I omega square. What is the formula for work done for the rotation? My work done for the rotation is nothing but tau multiplied by theta. Clear, brother? Brother, I just write all the formulas by using our chapter 2. And then what is the relation connecting torque and the acceleration? Torque, which is equal to I alpha. Clear? And apart from that, we have that equation, the 5 equations. So you have to use that equation by changing the parameter. Clear? Clear?
Doctor.
Okay, brother. Inshallah, we will solve the problems in next class.
Doctor, I just have one question. And center of mass.
Okay.
Can you go back, please?
I think it's chapter number 9. Am I right?
No, in this chapter, in this slide, we mentioned the center of mass with the velocity. You say
okay. You mean this slide? You mean this slide?
Yes.
Okay. For example, I will come here. Wait. I will just add one more. Okay, brother, listen carefully.
Okay. I mean, how it's come the equation?
Brother, wait. If any body is rotating, this is for my linear. Linear means all objects are focused on only one direction. This is for linear. Clear? That means translation. In other words, you can use the word translation motion. Okay. Now, if any body is rotating, listen carefully. Tangential acceleration we studied. Am I right? In this place, my object will be moving in this direction, and in this point, the object is moving in this direction. Right?
Yes, you're right.
There will be no velocity at the center.
Yeah.
If any body is rotating, there will be no velocity at the center. If any body is rotating, based on the linear, it has some speed at the top, it has the same speed at the center, it has the same speed at the bottom. Okay?
Can you say again this, the second?
When you take the linear motion, your speed at the top, speed at the center, speed at the bottom, all three are same. Okay. When you come for rotational, top, your force will be your speed will be in this direction. Bottom, your speed will be in this direction. Okay.
Yeah. And the middle velocity.
In the middle, your velocity is 0. Now, what I am going to do, I am going to add these two. Top with the top, center with center, bottom with bottom. Okay. So I can just draw this diagram again. Now you can see, compare this diagram and this diagram. My topper side is exactly in this direction. Likewise, here also same direction. So what is my magnitude? It will be very bigger. Am I right? Am I right or not?
Yes, because we added. Yeah.
I'm just adding the velocity. Okay. Okay. Let's come for the center. My center is in this direction, but here the center there is no velocity. So my magnitude is only half. Am I right?
Yes.
Correct. Let's come for the last one. Here my velocity is in this direction, but here my velocity is opposite direction. What should be the speed at the bottom? 0. That information are given here.
Just this information. Okay, about the equation of kinetic energy of rolling.
Okay, kinetic energy. Here, what formula we have? We have half mv square. Am I right?
Yes.
Here we have formula half I omega square. Am I right?
Yes.
So what is the total? My total is nothing but half mv square plus half. Clear? By merging these By merging these two, we got this formula. Am I right?
Okay, okay.
That information is given here.
Thank you, doctor.
Clear?
Clear, doctor.
Okay. So any other question from other side?
Thank you. Easy now.
But here, I just need the response from other student. I don't know how many of you are sitting here. I have no idea. I think 27 students, including me, 27. I don't know. Out of this 26, forget about me. Out of these 26 students, I don't know how many of you are sitting here. I have no idea. Because no response from others. Ahmad Bagar, Ahmad Yasser, Ali Hussain.
Everything is clear, doctor.
Okay. At least, brother, I finished the lecture from chapter number 10. At least you can type and you can say, yes, doctor, I understood. Finished. But no response from other side. What happened? Right there.
Sorry, teacher.
Huh?
Sorry.
My dear, listen carefully, brother. Actually, you have to interact with your teacher. If you ask more questions, then I will be more interested. Am I right?
Yes.
If you are simply sitting means I will feel bored.
Yeah. You will feel you are like talking to nothing. We are there
Yeah.
listening.
And that's what I said. Because I am explaining the formula, how we got the formula. I explain each and everything in the slides. Am I right?
All right.
Carefully, listen carefully. Out of this chapter, because you are going to write your final exam for 14 chapters. Out of these 14 chapters, you are going to use more formulas only from chapter number 10. How many formulas today we studied?
About 12.
Yeah,
But
more than
it's
12.
similar.
More than 12. More than 12. You can just you can just see the slide. How many formulas we studied? You can just go to the last slide. Let's we just count. You can see how many formulas you studied. You can see 5 equation. That means 5. 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16, 17. 17 formulas. Just imagine.
More than.
Of course, because sometimes, because you can see in this chapter, if you compare this chapter with other chapter, did you study 14 formulas from other chapters?
Yeah.
So please, brother, work hard. Okay, this is my request for you. Please try to concentrate on your final exam, and most probably, brother, listen carefully. Especially question from this chapter, you have to read it very carefully before you apply the rule.
Okay.
Clear, brother? Is there any doubt from your side?
Doctor, did you tell
Regarding?
according about the lab? You said yesterday something again.
Yeah. But your email is not in my inbox, brother.
Huh?
Your email is not
Now,
in my inbox.
No, in the morning I sent it again. Did you receive?
I will check and then I will let you know, inshallah. I will check
Okay.
and then I will send the message through the group, okay?
Okay. Thank you, doctor.
Okay, because till now I don't get any message from my mobile. So I will just check again and then I will let you know through the group.
Okay, thank you, doctor.
Okay, brother, take care. I think today, I think this will be enough because we
Doctor,
studied more than
just one question, doctor.
What?
Regarding the quiz, it will be Sunday or Wednesday?
You mean for quiz 2?
Yes, quiz 2.
Quiz 2, Wednesday.
Okay, thank you, doctor.
Wednesday, first period I will take the class, second period you are going to write the quiz, like your last quiz. Quiz 1 also you did the same, am I right?
Yes.
Same like quiz 1.
Thank you.
Bye, brother. Inshallah, Wednesday I will tell you the clear picture about the number of chapters. I hope 2 chapters will be considered for quiz 2. But anyhow, I will talk with our coordinator and I will give the clear message in the blackboard announcement. Okay.
Okay, thank you, doctor.
Okay, brother. Take care. I think still you have time. No problem. I think today this is enough. We studied more.
Doctor,
Yes.
I have a question on the last slide.
Wait. From this chapter?
Yes.
Yes. Which slide, brother?
The last slide about the question.
This one?
No.
This one?
No. One more. One more.
No, that's it. It's over.
Yes. The difference between target equal I alpha and equal R theta.
Brother, or? Ah, very good, very good. You're asking what is the relation between this and this. Am I right? Brother, if you have any question, for example, you have one question, in that question, if they give the moment of inertia and the angular acceleration, you have to use this formula, okay? If the question is related with some angle, radius and the applied force, then you have to use both formulas are related to the torque tau. Torque tau, which is nothing but Rf sin theta, and torque tau, which is equal to I alpha. Both formula are right for indicating the for explaining the torque tau. Okay, but the most important thing, if the question is dealing with any angle and force and radius, you have to use this formula. Clear?
Okay. When I have
If the question-
angle, I use the first.
Yes, because here there is no angle, right? Is there any angle here? So you have to use this formula for the angle. Okay.
Thank you, Doctor.
Okay, brother. Any other question, brother?
Doctor,
Yes.
I will send some message to private WhatsApp.
Okay. Okay, no problem.
Okay, thank you.
You mean private WhatsApp, huh?
Yes.
Okay, no problem. No problem. Okay, brother. I think our class is over today. I think today is enough. I don't want to go for up to 8:40.